everyone, and welcome to reInvent. I am Natalie White, and I'm an Enterprise Solutions Architect at AWS.
And my name is Mateo Rinaudo, a Senior Developer Advocate with the AWS CloudFormation Service Team.
And today we're going to talk about automating cross-account CI/CD pipelines. So let's get started. We're going to do a little introduction first about DevOps mindset and transformation. We'll walk through some really important considerations for your multi-account strategy. And then we'll have a live demo of automating a cross-account CI/CD pipeline and all of the steps that need to happen to make it successful. And then we'll talk a little bit more about doing cross-account CI/CD pipelines at scale outside of the application development domain. So when we start talking about DevOps transformation, that term can be very nebulous. What does it actually mean in practice? Sometimes it helps to think about it in a more concrete transformation that we might be a little more familiar with. And one of the most dramatic transformations is the life cycle of a butterfly. So we start with an egg that hatches and grows into a caterpillar. That caterpillar grows and forms a chrysalis, and that chrysalis forms a butterfly through a metamorphosis. And of course, that's not the end. The cycle actually starts over and continues over time. And while the butterfly stage may be the most beautiful, each stage has its own purpose and its own advantages and disadvantages. And it's no different with the DevOps transformation. When we start talking about DevOps transformation, we're talking about the transformation of people and processes and tools. So like the butterfly lifecycle, each stage has its own advantages and disadvantages, and we'll take some liberties with the number of stages since we're people and not butterflies. And when we start using the cloud or start using a new service in the cloud, normally we'll start with the AWS Management Console or the AWS CLI. We'll start to use that service individually, learn all of the granular features, how to configure it, how it can link up with other services that we may be more familiar with. But this becomes unwieldy very quickly because it's error prone because you're doing it manually. And if you need to do it over and over again, it becomes very time consuming. So pretty quickly, you'll want to transform your process and your tools to use infrastructure as code. So whether you're using CloudFormation or the CDK, being able to programmatically deploy resources and applications in a repeatable way is a great way to transform the process around deploying that infrastructure and those applications. The great thing about these tools is that kind of meet developers where they are. If your team or a single team member has more experience in the infrastructure space, they will probably just want to use CloudFormation, which is that hierarchical text file that defines the configuration around those resources. But maybe if you have team members who already have coding skills or they want to build those coding skills, you can start using the CDK, which has the same advantages as CloudFormation because it is CloudFormation underneath. And so being able to meet developers where they are and use these services in conjunction with each other helps your team to work more quickly and use the skills they already have to be successful. Now, these are great for accelerating what you're deploying into the cloud, but it makes it really easy to deploy everything into a single account. You can start building really quickly, and if you're deploying everything into a single account, your personas tend to have access to everything in that account kind of at the same level. Unless you get really granular with your IAM roles, you're going to have that same access across everything in the account. And if you're deploying multiple application environments into that account, that means you have the same access to your production environment as your development environment. And we advise best practices to kind of separate that access and limit access to least privilege. So the next step in that transformation process is to start using multi-account deployments to be able to create that separation with AWS accounts as opposed to IAM roles. So this still allows your developers to have access to what they need, but protects them from deploying things that they shouldn't, And it can be used for things other than application development, which we'll see later on in the presentation as well. And of course, that's not the end. The cycle is going to start over again. So if you start using a new service or a new piece of functionality, the cycle will start again, and you can start using new services with the same kind of mindset and transformation as you go along, whether it's a new service or a new application. So this multi-account strategy, the last step, is what we're going to focus on for this talk, and Matteo is going to tell us more about some important considerations as you go through this process.
So this is a 400-level session on the software development lifecycle, or SDLC, of an application that you will build, test, and eventually deploy across multiple accounts. But before we get into the details of the SDLC-specific account layout, why don't we take one step back and see, why are we even entertaining a multi-account conversation in the first place? What are key considerations you should make when you adopt a multi-account strategy? So the first thing to consider is, an AWS account provides you with the highest level of resource isolation. And this means that you can choose to create discrete AWS accounts for all of your business units, for all of your different workloads. They may or may not have different requirements, including data isolation requirements or data sensitivity requirements. And you can also choose to have local administrators on such accounts to administer the life cycle of resources that you will deploy into those accounts, or you can also choose to have mechanisms and processes that manage resources on your behalf. And we're going to see an example later on with continuous delivery pipelines. Another consideration to make is, in the event of an account suspension, for example, or a security breach, when you adopt a multi-account strategy, you have the ability to mitigate the area of impact. Another consideration to make when it comes to multi-account strategies to adopt is service limits. Should you have any requirements to impose service limits on a given workload for a given account, such as, for example, I have a requirement, or I would like to not to be able to launch more than X amount of Amazon EC2 instances of a given type on one account. With a multi-account strategy, you can do so without impacting other workloads and other resources that you're going to be deploying into other accounts. So it can impose limits on a given AWS account. Another consideration to make is the visibility of workloads. By default, unless I give another user that is in another AWS account the permission to consume, the permission to discover, the permission to consume my resources, they cannot do that. So a multi-account strategy helps you with workload visibility, in the sense that you're going to be limiting, you're going to be avoiding other users to consume, view, and discover resources that you have in your account. And then last but not least of these key considerations that we want to make is data isolation requirements. So think of all of your requirements in terms of, I want to run application A in account A, and then I want to log everything into account B, which is most likely a centralized account. That's where I store centrally all of my logs. That's where I can audit these logs. That's where I can analyze these logs. Or I have one or more separate accounts where I store data that I can use in the event of a system restore is needed, like backups. So those are key considerations that you should make regardless of whether you are ready or not into adopting an SDLC process. So let's transition into the software development lifecycle aspect of a multi-account strategy. Let's go one layer deeper. What are key considerations that we should make that you should make when it comes to designing the account layout for your SDLC. So the first thing you want to consider is, how do I separate the control plane, which is your tool chain composed of continuous delivery pipelines, for example, from the actual application that you are deploying, which is going to be your data plane. So you want to keep them separate. And the first thing that you want to do is, I want to consider having one or more AWS accounts where I can store, where I can manage the control plane aspect, such as mechanisms and processes that you build and configure to deploy applications and workloads on your behalf. So once you have this account where you're going to be storing your continuous delivery pipelines, you're going to have one or more pre-production accounts. We're talking about the life cycle of your application. Think of environments such as, for example, dev, QA, pre-prod. That's where you start your continuous delivery phase or continuous deployment, depending on how you transition into production. And that's where you deploy your application. You perform all the tests that you need. There are tests that are more and more strict as you progress to production. Acceptance, regression, load testing, and so forth. And then eventually, the production account. This is where the pipeline run ends. That's when you deploy your application that you have thoroughly tested, starting from the continuous integration phase and then continuous delivery into pre-production accounts. That's where you monitor and keep monitoring your application. And that's where you get feedback from your customers. And that's where you start the life cycle of the chrysalis that Natalie was talking about. So once I have this very high-level idea, those are the accounts that I need. This is the structure that I like to have. Now it comes to think about, how do I build the process or the processes or mechanisms that are going to be building, testing, and deploying my application on my behalf. So what I want to do is, and this comes as no surprise, I would like to use automation, because once I have tooling and processes that I can describe with code that are easy to audit, that are easy to test, like if they were an application, then this is not only less error prone, right, but also gives you back time to innovate faster on behalf of your customers. So what you want to do is, you want to start deploying some capabilities, give you the ability to build, test, and deploy across multiple accounts. And the first thing that you want to use is IAM roles, AWS Identity and Access Management. The AWS service that gives you the ability to say which principles, which entities can do what on a given account. So what you need is accounts in the tooling account, IAM roles into tooling accounts, accounts, and IAM roles into pre-production and production accounts, so that the tooling, the IAM roles that you have in your tooling account can assume roles into the data plane accounts, such as pre-production and production, roles that in turn you configure to set up the roles in the tooling account, so that you can assume a role in the pre-production and production accounts and deploy the resources that you need. So what I want to do is, you want to describe these roles with code programmatically, and in this example, you can use AWS CloudFormation templates, or you can use the AWS CDK, depending on the personas, as Natalie was mentioning. And typically, you have your security team in your company, or a team of developers that, on behalf of the security team in your company, describes this role programmatically. Next, once the team has chosen which tool to use, in this case, CDK or CloudFormation, well, in the end, they're going to be using CloudFormation anyway, right? You want to start deploying these resources into the tooling account and to pre-production and production account. So you have your baseline from an identity and access management perspective. The next phase is, you want to start deploying your tool chain. So you have either the same team or another team or lead developers that are going to be describing with code, and this comes as no surprise as well, the control plane. So what you need is one or more source code repositories and a continuous integration delivery orchestrator or deployment orchestrator, such as a pipeline. So the lead developer describes such resources and deploys them into the tooling account. In this example, today we're using AWS Scale Commit for the former, for the source code repository, and for the latter, for the pipeline orchestration, we're going to be using AWS Scale Pipeline. And of course, the lead developer has configured AWS Scale Pipeline that we are using in this example to perform all the actions that you need from a continuous integration perspective, fail fast, static code analysis, and so forth, and then how to assume roles into pre-production and production accounts for the pipeline to deploy resources on your behalf, as the pipeline ingests all the code that comes from the source code repository. Okay, so now we have roles, we have the control plane. What about the data plane? That's where the application team in this example comes into place. So today we're going to be showing an example of an Hello World style API that is going to be using Amazon API Gateway and AWS Lambda as the front end and as a back end, respectively. So imagine a team in a company that is composed of developers, right, that are describing the infrastructure of the API and also the code that they bring to AWS Lambda. So what they do is, first, they use their own machines to build and test and deploy locally their application. They have choices. For example, they can use the SAM CLI, SAM local for the testing and development. They can choose, depending on the choices that the company has made, tools such as AWS CloudFormation Linter or CFL Lint to validate JSON and YAML CloudFormation templates against the AWS resource specification. Or, for example, the company can choose to adopt the AWS CloudFormation Guard or GUARD, so where the security team writes rules for policy compliance, so that developers can consume those rules locally and test that their CloudFormation templates, either the ones that they are creating or the ones that are synthesized by AWS CDK, are compliant against those rules. For example, I want to enforce versioning enabled on my buckets, or server-side encryption is enabled in my bucket. So once developers are ready to share the contributions in the source code repository, they can do so. And they will be using the control plane that we discussed earlier, whereas the source code repository in this case is AWS Scale Commit, and the developers can share their contribution into a given branch. The AWS Code Pipeline that the lead developer or the team that is managing the control plane has configured to listen for changes on a given branch will start consuming these artifacts that are going down the pipeline, and eventually you're going to be able to deploy to pre-production and production environments. And of course, before you do so, before you transition into the continuous delivery phase, which is when you deploy into the data plane, you also want to enforce, you want to choose to enforce actually in the continuous integration phase of your pipeline. For example, using AWS Code Build, you can do and enforce the same tests that developers have done into their machines, such as policy compliance tests, unit tests, or contract tests, or what have you, CFL Lint, and so forth, so that you have an opportunity to fail fast should any errors come up before you even start deploying into even the dev environment that you have in pre-prod. So this is basically the high-level vision of how to leverage more than one AWS account for control plane and data plane. And we have also gone through a process of how to deliver an application using tooling that we discussed about. So with that being said, I would like to give it over to Natalie for a demo on how this will work.
All right, here we are in our pipeline or our tooling account.
And you can see here that we don't have any CloudFormation stacks deployed yet, apart from the one that gets deployed when you bootstrap the CDK against an account in your development environment. And you can also see we don't have any code pipeline resources deployed at all yet either. We're going to deploy everything from scratch here as I'm walking through the automation code. So let's switch to my IDE, and I'm going to go ahead and kick off the deployment script and just let it run here in the background while I'm talking about the solution. The demo code consists of two CloudFormation templates that define the roles in the that the pipeline account needs to assume in each target account. It's got three CDK stacks, one for the code commit repository, which is separate from the pipeline in case you ever want to blow away the pipeline but keep your code. There's a CDK stack for the application with the API gateway REST endpoint that's backed by Lambda. And then there's another CDK stack for the pipeline that actually deploys the application to the target accounts. And last but not least, I have a couple of automation scripts, one for deployment and one for cleanup. So we're going to walk through them in the order that they're used for the deployment so you can see how they're all linked together. It's going to be slow at the beginning because we're going to talk about IAM roles. But let's walk through the deployment script here at a high level and get a feel for what's going on kind of here in the background. So we're going to verify there's some prerequisites that have to happen before you can run the script. This is a 400 level session, so we're not going to dive deep into how to set up credential profiles or set environment variables or bootstrap the CDK or any of that. We're going to jump right in. So we're going to check on the environment variables that we're going to reference as a part of our deployment, and then we're going to start deploying the roles to the target accounts so that they exist when the pipeline is created. We're going to start by deploying CDK stacks, one for the repository and then for the pipeline. Obviously, we're not deploying the application stack because that's done by the pipeline. And then you'll see that actually we're going to call the CloudFormation deploy command again with the same role CloudFormation templates. And you probably didn't miss the fact that why are we doing this twice? Why do I have to do that? Well, it's because there's actually a circular dependency among the roles and the pipeline that the roles have to have already been created when the pipeline is deployed, because the pipeline has to reference their ARNs to tell the pipeline what roles to assume as the pipeline runs. So the roles also need policies attached to them that will allow them to access the S3 bucket and the KMS key that are a part of the pipeline stack creation, which hold all of the build artifacts for each of the stages in the pipeline. So the roles need things that are created by the pipeline. The pipeline needs the ARNs of the roles. You see the circular dependency here, right? So we'll take a step back here. For cross-account pipeline actions, you have to set up S3 bucket encryption. You should set up S3 bucket encryption anyway, but you definitely have to do it for cross-account pipeline actions. And you can't use the default key that comes along with S3 encryption because you can't update the policy on that key. But the key that's encrypting your build artifacts, you have to update the policy on that key to allow the UAT and production accounts to access the build artifacts that are a part of the pipeline. So you need to create your own KMS key. So that's one of the outputs of the pipeline CDK project. So I've set up these role CloudFormation templates to be deployed twice. The first time, we won't provide them with a KMS key ARN, so only the role will be deployed. We need the role ARN for the pipeline. The role won't have any policy attached to it. After the CDK pipeline is deployed and we have a reference to that key ARN and the S3 bucket has been created, we'll run the CloudFormation templates a second time with that reference to the KMS key, and that will update the policy that is attached to those roles that will allow those roles to get access to the S3 bucket and the KMS resources. So all of this complexity is automated with the script, so it runs in sequence in a few minutes, and we're going to dive into the CloudFormation templates here so you can see what the roles look like? What do they look like in practice? Before we dive into the actual details of them, let's talk a little bit about why I use CloudFormation templates instead of, say, creating another CDK project to define these roles. Number one, I wanted to showcase the fact that even if you're using the CDK for a part of your automation, doesn't mean you have to use it for the whole thing. And this also gives you an example of how different teammate personas can work together to build independently. Maybe these cross-account roles are being created by the security team or the infrastructure team who are more used to that hierarchical definition as opposed to writing code. And then your applications are obviously going to be created by developers who are much more comfortable and would probably prefer to write code instead of CloudFormation templates. So creating another CDK stack just for these roles means I would have operational overhead of having another build process to synthesize the CDK into CloudFormation. And really, these roles are less than 100 lines of CloudFormation anyway. They're not going to change frequently. So keeping them as YAML files is totally reasonable. You can do your own advantage and disadvantage comparison for your own use cases. But for these roles, we'll just use CloudFormation in the AWS CLI. So what's actually in the templates? We're taking in several parameters. This role is for code pipeline to use. So as a part of each code pipeline stage, specifically the deployment stages, we need to have roles that the tooling or pipeline account can assume to execute actions against the target accounts. So we're going to use the tool account ID, which is going to be passed in with an environment variable. And we're going to have a reference to the key ARN. Now, both of these are really used to reference the S3 bucket, but the key ARN specifically is what's going to trigger the condition of whether we deploy the policy or not along with the role. So if we don't have the key ARN, we're not going to deploy the policy. So the first go around, we won't give it the key ARN. We'll deploy the role, which allows the tooling account to assume the role in the target account, but this condition will keep it from deploying the policy that needs the reference to the CDK artifact. So hopefully this is making sense now that we're looking at the actual code. We'll look at the actual policy here since we're already in the file. We need access to be able to execute CloudFormation actions. We're going to pass roles on through IAM, and we need access to the S3 bucket that will be created by the CDK pipeline stack and the KMS key that I referenced earlier. So hopefully this makes sense now that we're in it. The second role has a few differences, but is very similar. The second role is a CloudFormation deployment role. So as a part of the pipeline, we're going to have deployment stages. Those deployment stages are going to use the code pipeline cross-account role to execute a CloudFormation deployment against the target accounts. And so this role needs access to more actions and more services than the previous one did. So we're going to take in the same tools account ID, the same key ARN, but we're going to add to the complexity and take in a stage environment variable as well, or a stage parameter rather, not an environment variable. So this is a part of the deployment, and the reason we need this, either prod or UAT, is because for each target account, they're going to have their own synthesized CloudFormation template as a part of the CDK build, and they're going to be prefixed with the stage that they go with. So we're going to deploy the UAT application deployment template to UAT, same with prod. So then we have the same condition that's going to determine whether we deploy the policy or not. We're going to deploy a role, and it's going to allow us to execute CloudFormation actions and assume the role from the pipeline account. And then we're going to use that same condition to determine whether we're going to deploy the policy. And this policy, again, has additional actions that the other one didn't. There's going to be some IAM roles and policies that need to be created either for services that are deployed as a part of the application or on behalf of CloudFormation itself. We need access to code deploy, Lambda, and API gateway, which are all a part of the application. And then we need access to the S3 bucket and the KMS key, again, like the other role. Obviously, we're going to need CloudFormation action access as well, and the stack that we're going to deploy in each of those target accounts is delimited by that stage that we took in as an input. All right, so those are the two roles. We're going to deploy instances of those into each target account. And we're going to go back to the automation script right now. Once those roles have been deployed, we're going to deploy the repository stack, which is going to happen here, right? We're going to build locally all of the artifacts we need to deploy the repository stack. And then we're going to deploy the cross-account pipeline stack. So this call is a little bit more complicated because I'm trying to take the output into a file and grab the output from that CloudFormation stack. There's only one output actually, it's the key ARN, and we're going to use that key ARN to be able to execute that update for the roles in each account. So now you can see through the automation script what that looks like. We're using the output from the previous deployment step to be able to update the roles in the subsequent step. All right, so what are we actually deploying as a part of this pipeline account? Let's go look at those files. We're going to kind of work backwards and start from the Lambda code that's going to be deployed. It's super simple. It's going to say hello from the UAT or prod environment. It doesn't really matter what we're deploying. I wanted to keep it really simple, just not to confuse the issue. What we're really focused on is how to orchestrate the cross-account deployment and pipeline, not so much what's being deployed, but we'll see how this is successfully deployed here in a minute. The actual application stack is going to use that Lambda code to build a Lambda function. All of this is super vanilla. We're going to use that Lambda function as a part of the Lambda REST API with API Gateway. And we're going to create an alias and a Lambda deployment group that goes along with the application. Again, very simple application, nothing too fancy. The pipeline is where things really get interesting. So far the stacks have been relatively simple, but this pipeline stack is actually just over 230 lines of CDK, which is synthesized to over 2,000 lines of CloudFormation, which would be really difficult to manage as a single text file or even a set of text files that are referencing each other. So using the CDK makes a lot more sense if your team has or wants to build those coding skills. So I'm going to show you kind of what that looks like here. The application stack is going to be used by the pipeline stack. So we're going to have a reference to both the UAT and production versions of that. And we're going to pass in the UAT account ID and the prod account ID as well as those environment variables that we saw in the automation script. So we're going to use the repository that we created in that previous CDK deployment, and we're going to start resolving the ARNs of the roles that we need in each target account that are going to be used by the pipeline. So we're going to use those account IDs that we passed in as parameters and the names of the CloudFormation roles that have been deployed to build up those ARNs. If we hadn't deployed the roles before we tried to deploy this, we would have gotten an error right here because those roles would not have existed and AWS would not have been able to resolve those ARNs. So that's why we have to deploy the roles first. So we're going to do that for UAT and for production, and we're going to resolve the ARNs, or really the root principal ARNs for both deployment accounts. So once we're done getting all of those prerequisites, we're going to start creating actual resources. So we're going to create our KMS key. Again, we're going to grant decrypt permissions for that key for the code pipeline role, because code pipeline needs access to the build artifacts for previous stages, and the UAT account role principal that will allow us to get the artifacts from the Lambda build as well. And then we're going to create an S3 bucket that uses that encryption key as its encryption method here. And we're going to grant read and write access to the production and UAT accounts as well. again, we need to be able to grab previous artifacts from previous stages as well as write output artifacts to that S3 bucket. So we need both there. All right, after that, we're going to start defining the pipeline. We have very vanilla definitions for the CDK build, which is going to build the application stack. We're going to use the prod and UAT application stacks as our build artifacts, and we're going to specify that we are going to use this encryption key when we store those artifacts into the S3 bucket. So don't forget to specify the encryption key at each stage because it's going to be needed to be able to store objects in that S3 bucket or grab them out. Same vanilla definition for the Lambda build. We're not going to dive deep into this because it's something that is not super complicated again. Again, we're going to use that encryption key here as a part of that build artifact storing. And we're going to define the output locations for each of those. So those artifacts that we just stored or defined in the build spec, we're going to put those into S3 basically. Now we can use all of those resources to be able to define our pipeline. So again, nothing groundbreaking on the actual pipeline definition. We've got our source, which is going to be triggered by pushes to the main branch of our repository. We have our Lambda and CDK builds that are going to be executed after we grab our source. And then this is where things get a little bit more interesting for the deployment stage. So I've defined it to be a CloudFormation create update stack action. Very standard definition of that deployment action as a part of CloudFormation. We're going to use the UAT deployment stack to deploy to the UAT environment. But the difference will be that the roles that we define here in this deployment stage are the same roles that we just went through in the CloudFormation templates. So the UAT code pipeline role is the role that's going to be used when we're executing this code pipeline stage to deploy to UAT. And when that CloudFormation deployment is executed, it's going to use the UAT CloudFormation role to deploy into the UAT target account. So these roles and the access that they give against those target accounts define how that CloudFormation template is going to be deployed into the target account. Okay, same exact thing for production. We're going to use the production application deployment stack and then the prod roles that we defined to deploy the application into the production account. So that's our pipeline. After we define our pipeline, we're going to add the UAT and prod accounts to the pipeline policy, and then we're going to publish that key ARN to our CloudFormation outputs, which is used in the subsequent deployment and update of those roles and the policies that are associated with them. All right, so we've told the whole story. This is what the pipeline's going to do. Just FYI, the pipeline creation will immediately kick off the pipeline, but since we haven't pushed anything to the repository at that point in the automation script, it's going to fail at that source stage because we haven't committed anything. So that's our last step in the automation script. After we've deployed the CDK pipeline and redeployed the roles and now policies for each of those target accounts, we're going to commit the code to the repository, which will trigger a fresh pipeline execution and hopefully our first successful pipeline execution into the target accounts. So I have this helpful message here at the end of my pipeline run. You can see it successfully ran. And I'm just going to copy and paste these to the command line here. We'll get the endpoints for our deployments. Okay, before we actually go visit the deployments, we'll go back here to our CloudFormation stack. So this is in our pipeline account, right? We now have our pipeline stack that was created, right? Here's our repository, here's our pipeline stack, and all of the resources that are associated with it. So you can see all of the resources we defined, they've all been created. And then in code pipeline, we'll refresh the screen here. Here's our code pipeline. Hooray, it was successful. And you can see here we've got our source, our build stage that has the Lambda application and then the CDK part. And then we have our successful deployments to UAT in production. So let's go back and we'll access these URLs. Hello from the UAT environment. And hello from the prod environment. So we've successfully deployed our application across accounts. All of it was automated in less than the 20 minutes or so that this demo took to complete. And now we can move on. Now that we've walked through all of the prerequisites, all of the deployment steps, all of the configuration that has to go into the pipeline, we're ready to deploy our application as many times as we want. So our developers, they have the access that they need. Each of our environments is totally isolated. You'll notice I didn't need to get into the console at all for either of my account deployment things. I can just use the CLI and the access that I have, so you can limit your access to whatever access that you want people to have. And this doesn't have to just be used for application deployment. So Mateo is going to talk about kind of the next level of being able to use cross-account pipelines to be able to scale those deployments across hundreds or thousands of accounts in the management and governance space.
Okay, thank you, Natalie. So what we have seen is an example of a software development lifecycle, or SDLC, of a given application across accounts. So now I would like to share with you an example use case that I think applies to any organization of any size, small, medium, or large. Even before I start thinking about adding workloads or building applications, such as the one that we have seen earlier, into an account, what I want to do as part of best practices is to make sure that I have, from a security management and governance standpoints, the right guardrails that I need, that I require. So how do I do that at scale? So even if I have 1, 2, or 3 accounts, or hundreds or thousands of accounts, as part of best practices, from a repeatability, from a predictability perspective, and also from a growth at scale, the last thing that I want to do is I want to set up, test, build, test, and deploy actually all of these security controls manually, right? So I'm sure you folks might know where I'm going with this, but what I want to say is treat all of these security controls as if they were an application, like the one that we have seen earlier. So this way, you're going to have a predictable mechanism and also a vetting mechanism that you can leverage to check that these security controls work the way you want before you share them with the entire organization. And here is an example. This is going to be very similar to the use case that we have seen earlier. So you're going to have a central or centralized AWS account where you're going to be putting your tooling, and a number of AWS accounts for all of your business units, for all of your applications, for all of your workloads. And your goal is for each one of these accounts to have the security management and governance controls you require, configured the way you want. And of course, you want to manage their life cycle. So it's not just deploy once and that's it, right? All of these resources that you want to deploy will have a life cycle. So you also wanted to make sure, how do I do that at scale? So this is the problem statement. So connecting the dots with the previous example comes as no surprise. You want to use a continuous delivery process to build, test, and then eventually deploy all of the security controls. It's pretty much the same conversation that we got earlier. So the first thing that you need to do is choose a tool. For example, in this session, we are showing AWS CloudFormation, the service, or AWS CDK that you can choose depending on your personas. And the security team in your company, once they have made the choice of the tool to use, they will need to describe with code the roles, like we have seen earlier for the application, and then deploy those roles across accounts. Then, like we have seen earlier, you're going to have, again, the control plane composed of a source code repository or more than one source code repository, and a pipeline orchestration tool that is going to be deploying the applications on your behalf. So it could be the same team, it could be a different team. So once you have described this control plane, then it comes to describe what? The data plane. The data plane in this case is security controls that you want to enable across all of your accounts of your organization. So you have a team in your company that works on describing with code security controls that you require. Then with the same considerations that we have made earlier that still apply here, all the tasks that you can do locally with the tools of your choice, whenever the contributors are ready to share their security control code changes into the source code repository, that it can push the changes into AWS code commit, for example, that we are showing here in the tooling account. Then the pipeline will listen for changes for anything that comes from the source code repository, and then it will deploy on your behalf based on the configuration that you have applied to your pipeline into all of the accounts that you have. And security controls, for example, include AWS Security Hub or Amazon GuardDuty or AWS Config Rules or AWS Systems Manager resources. So how do I do that at scale? With automation. Let's take a closer look into our automation process. So let's start with our orchestrator. In this case, we are leveraging AWS Code Pipeline as our orchestrator layer. With that, we have another component, which is one of the accounts that you may want to choose among the accounts that you have in your organization. And that's a sandbox account that you will be using to check if security controls that you deploy as part of this process work the way you expect. We'll take a closer look in a few moments. So, pipeline orchestration and an account where you deploy your security controls and where you check that your security controls work as the way you expect. Next, source code repository, a single source of truth. Everything must be described with code for changes to be audited to see who and when a change was made, who made the change and when. Then you have code build, again, where you perform all of your checks depending on where you're deploying, typically linting, unit testing, and so forth, static code analysis, policy as code checks. And whenever you're satisfied with all the tests that you instrument, that you configure into your continuous integration phase, here depicted with AWS Code Build, then it's time to let's try out these security controls. So what you want to do is you want to describe the deployment process using, in AWS Code Pipeline parlance, a provider. In this case, we're using AWS CloudFormation to deploy into the account two things. So first off, your security controls. And then second of all, with one or more separate templates, resources that you have for testing purposes configured to be not compliant. For example, if in your organization you require server-side encryption, a REST for a Strip bucket, and you should, right? Security is job zero. So, you also require, for example, that all of your Amazon Strip buckets must be configured with versioning enabled. So for example, you can just describe a private S3 bucket with no versioning enabled, with the CloudFormation template, deploy that into the sandbox account, and validate that your security controls pick up the fact that the versioning was not enabled or server-side encryption was not enabled, and detect and remediate that. So for that, you can use an orchestrator such as AWS Lambda, for example, with code that you bring into AWS Lambda that performs all the checks that you need. So you describe with code all the tests that you want to perform to make sure that you get all the data that you need. Because eventually, what you want to do is you want to present all of your auditors or security team members with results. This is what my security controls have detected as part of our test cases, and this is relevant remediation. So that in the next phase, you're going to have a vetting process. Initially, what you can do is you can instrument a manual approval step in your pipeline, for example, for AWS Code Pipeline, so that the pipeline execution stops for a moment, so that members of the security team have time to review all of these test results that you are providing as part of what we had discussed earlier as an evidence. And if members of the security team are okay with all the results, they can choose to approve or to reject the changes. If they choose to approve changes, then the pipeline that you have set up will then assume roles into target accounts, as we discussed earlier, and deploy across all of your accounts all these security controls. Then let's take a look at this bigger picture. So now we have a mechanism that gives you the ability to build, test, vet, and deploy your security controls. What are the key takeaways here? There are at least two things, right? So first off, since now you have a predictable mechanism to build, test, and deploy, build, test, vet, and deploy changes, anybody in the organization who is empowered, who is authorized to share their contributions with the source code repositories that host all of these security controls code, they can do so. They can unblock themselves. So this means that at the same time, the security team has more time to use for other activities, right? And for example, they may choose to say, I want to start building capabilities so that in the future I can swap out this human-driven scrutiny that is my manual vetting mechanism with building tests that I will want to trust 100%. So I want to make sure that I execute this right, so that all of these tests are automatically vetting all the test results, and then in a continuous deployment style, deploy all the resources across all the accounts. Okay, so with that, I would like to transition back to Natalie for some final thoughts and a recap of what we discussed about today.
Thanks, Matteo. So today we talked about the DevOps transformation mindset. We talked about some important considerations in your multi-account strategy, showed you a live demo of how to automate a cross-account CI/CD pipeline deployment, and how you can use it outside of the application deployment space into the management and governance domain. So keep in mind, this is all about people and processes and products. And we can't wait to hear how you start using cross-account CI/CD pipelines to accelerate what you're doing on AWS. Thanks for joining us. We'll make sure to publish the code so it's publicly available to you, and keep on building.